Well, hi. Welcome to GradStats 2024 Lab Series. In Lab 1, we are working with data. And this first lab is to build your skills using the RStudio interface for some basic tasks. We're going to import a data file, explore around the data file a bit, do some cleaning, evaluate the internal consistency of scale items, and create a couple of scale level variables. Now, materials you will need for this lab include the CSV dataset, the codebook from the SPSS Survival Guide for the survey dataset, and for R, we need the Lab1 script to work with. You'll find these materials linked in the description. So download those and let's get started. So opening up RStudio, we have our panels. We can expand the script panel with our little tabs there to arrange. We're pretty much using these for most of the time. Our script, our console, our environment, and everything else. And downloading those files, both your R script and the CSV, you want to put them in your working directory. So you want your CSV file in your working directory, and you want the script that you have access to through a link in the description. Loading up our script file, all we got to do is click it, and it loads up. And then we have pretty much walkthrough directions here. And again, our goals, we want to use this R script to leave notes to ourselves with the comment hashtags, so that when you look at your script later, you're able to see what you were doing and be able to use it in the future, whether it's a future homework or a future data project that you're working on or a future in the field. So you want to leave yourself lots of good notes. But we're going to import the CSV, clean some data, assess internal reliability of some item level variables, and create scale level variables. First thing we need to do is install and load packages that we're expecting to use. So I want you, any place you see these blocks at, that's where I want you to put in your code and save it here in your script for turning in later. So this would be install packages tidyverse. And I'm on a Mac. If you're on a PC, you use Control. If you're on a Mac, you use Command. And I'm holding the Command key to hit Enter, and that sends this command to the console down here, which is good because then you keep your code, what you did, up in your script, because you don't really keep the information from the console unless you put it somewhere else. And then once I've installed the package, I can load it through the library function. So again, command return will run it. Need to do the same thing with the psych package. There we go. So now we want to import our data file, and we also need to have the codebook for the data file as far as materials. And keep saving your script so that you have it ready for turning in later. As long as your data are in the working directory, you can read them in through a function called read CSV. So I'm going to try this. I don't know. There you go. It's got error because I haven't set the working directory properly. So I'll go back and do that. Global options. 2024. Now this should work, unless I have to restart. No, looks like I'll need to restart to get the global directory to take effect. So. When you restart R, it takes out anything that you have loaded. So even though the packages are still installed, like if I go down to tidyverse, so it's installed, but it's not loaded yet. And like we saw on orientation, you can load by just checking the box, or you can load by sending the command. But I'm going to go back to our script file and start with that. So this is already installed. I just need to reload it. So now I have tidyverse and psych reloaded. And let's see if this read in of the CSV data works this time. There we go. So that's what happens when you have the file properly in your working directory, is that it just jumps right into your environment. We have 439 observations of 118 variables. However, when we fold down this object in the environment, we'll see that the variables all came in as numerical or continuous variables, which is not the case. So first, let's change the ID variable to a character, which is going to be like a nominal variable for us. Anytime you see these, it's for you to put some code in. We want to say lab1, the variable ID, we want it to be assigned by or changed to as a character type. Which variable are we changing to a character? The one that's lab1 variable ID. So we're writing back onto that variable. It's kind of like recode to the same variable, but we're changing the type of variable there. I'll take off the hashtag so that we have a command and command enter. Now that changed the type over here in the environment for that variable ID. And then notice that our categorical variables are numerical as well. So we need to look to the code book for guidance here. And I'm going to go down to the third page that we see that sex is categorical, age is continuous, so we can leave it there. Marital is categorical, child, highest level of education, major source of stress, and smoke. All of these variables should be categorical except for age. So let's work on those. What we'll do is convert them to a factor, but now we're going to treat it more like recode into a new variable, and that is handy for when we want to keep the original variable handy for whatever reason, for an analysis that might need only numerical data. So what this code says is create a new variable called sex.f, and that's just the name I gave it. It doesn't have any significance other than I know by looking at it that I took the sex variable and I made it into a factor. And a factor is what we call a categorical vector or categorical variable that has levels. And the sex variable has levels of male and female. And you have to put those labels in the same order that they are coded as in the data. In other words, you had to put males before females. If you put them in the other direction, if you did females first, then all the ones would be reassigned to female instead. You don't want that. So you have to list these in the same order as they are appearing. So that's what we're doing there. I'll go ahead and run it. And you'll notice it didn't change over here, but that's because this is still the old variable. The new variable is sex.f, which is at the very end of this. Again, reading through that code, you want to just practice reading through our script code. This says lab, assign a new variable into the lab1 dataset called sex.f. It will be a factor with the following arguments. It's main from the variable sex in the lab1 dataset, and the levels are male and female. So using our data wrangling tools, we can take a look at these. We can select lab1 sex and sex.f and have that in our console. Looking at this, we see that 2s are female, 1s are male. That's good. That's what we want. So I want you to do the same in creating these other categorical variables in the data set. Again, like a recode to a new variable for marital, child, education, source, and smoke. What we can do is just copy this first one. I'm going to do Command C, paste it down there, and just change the information you need to change. Okay, now that we're ready with all of that code, I can take each one and run it, and I don't have to be to the end of the line to be able to run it. As long as I'm anywhere in the code, I can go ahead and run it with the command return. So that's marital, child, education, source. I'll have to go back and look at that one. And smoke. Let's take a look at error factor source. Invalid labels length 7 should be 1 or 9. Let's see what it's doing there. We found that there's actually a couple more. When we look at source, we're only given 7 categories. However, if we look in the CSV itself, there's also 8s and 9s included, and I think that is what is tripping out RStudio right now. It's like, okay, but what do I do with these other 2? So what we're going to do in RStudio is add 2 more here. 8 and 9, just because the code book does not tell us what those are supposed to be. So let's see if that does not give us an error in RStudio. Yep, it liked that better. So when there is data there, we're changing to a factor, you do need to have enough labels for however many levels there are in that variable. So that's good to know. Okay, now that we have those all converted to factors and labeled, this is a good place to save both your R script up here and the data frame. To save your R script, you're just going to hit the Save button. You can do a Save As and give it a more descriptive name if you want, but Lab1 script is fine. And then for the data frame, you're going to tell R to take Lab1 and output it to a file that is Lab1 RDA, and RDA is our data frame. So doing that, and where does this file go? Well, it goes into your working directory, wherever you've set that up to. So make sure you know your working directory and that all of the things you save are going to end up there. Next, we're going to assess the internal reliability of total optimism. Now, this is the scale that when we look at the code book, shows us that one right here, it's 6 items from OP1 to OP6 on a 5-point Likert scale of agreement. However, we need to reverse items 2, 4, and 6 in the total optimism scale before we do internal consistency evaluations and before we create the scale score for it. So we got to take care of those first. In R, what we want to do is kind of have a reference point to look back to. So giving just the head row and the first few variables or values in this variable OP2 is what we're calling for there. And the first values are 2, 3, 1, 1, 2, 2. And I went ahead and put them in the script as well so that you have them handy instead of trying to look through the console. So now we're going to mutate. We'll use our mutate function to create a new variable called REV OP2. And that's just the name I gave it. You could have given it the OP2R name. Either way, that's just what I chose to call it. And to make that, it's going to be the recode function of OP2 where 1s become 5s, 2 become 4, 3 become 3, 4 become 2, 5 become 1. Now I need to go ahead and do this for OP4 and OP6. So I can go ahead and copy this line and then update it. Same for, I'll need OP6. So that will set up the reverse coding for those 3 items. And this should be ready to run. I don't have any errors, that's good. And now I want to go ahead and take a look at these. Like, what is the first values of this new reversed OP2? They are 4, 3, 5, 5, 4, 4, which is what I would expect if at first they were 2, 3, 1, 1, 2, 2, right? See how they're reversed? In fact, it's best to just go ahead and confirm all of your reverse coding. You can kind of have a double header where we get the head values of OP2 right beside the head values of the reversed. So if I run that one, now they're right beside each other in the console. So that's handy. There's OP4, and we see that it's been reverse coded correctly, and OP6 has been reverse coded correctly. Always a good thing to check. Now that we have those required items reversed, we want to see if these items have enough internal consistency or reliability to combine to a scale level score. And we do that with the function, or with looking at the Cronbach's alpha. To do this, we need the library for psych, if you haven't already loaded it. And the function is called alpha. So I want Cronbach's alpha using dataset Lab1, and I want the items from that dataset of OP1, reversed OP2, OP3, reversed OP4, OP5, and reversed OP6. Running this. Now we can take a look. So we have the alpha coming in at 0.8, and we have item statistics. Okay, reliability if an item is dropped. So if we did not include OP1 in the total score, our Cronbach's alpha, or internal consistency, would be reduced to 0.79 from the 0.8 that it is. And looking across all of these items, all of them would, if I took out any of them, it would reduce the Cronbach's alpha estimate for that scale. And when it comes down to it, they're all at 0.7 or greater anyway, and that's our cutoff. We want at least a 0.7 to know that that item hangs well with each other. Those items hang well together. So looks good here, and we can move on to creating the skill level score. To compute our skill level variable for total optimism, we sum all the items together. So what we're saying here is take Lab1 data set and make a new variable. So the $ is, now this is a variable coming up, new variable called TOPTIM. It's assigned by the sum of the row for these items. And the NARM true means that if there are any missing values, to just ignore that. Like, just use the values you have. Don't worry about if there's any that are missing. So now that we have everything done for total optimism, we're going to compute another skill level variable, this one for total life satisfaction. And first, again, we'll check the internal consistency of the LifeSat items. And we can simply grab our coding from before for requesting Cronbach's alpha and paste it down here, and then update so that we have the right items. Now, I don't need to reverse code any of the LifeSat items because according to our code book, none of the LifeSat items need to be reverse coded. So we want LifeSat 1 through LifeSat 5, and we just want to find out how well these hang together. So all right, and does it match? It ends in parenthesis, bracket, parenthesis. Same here. So this should be ready to run. Alrighty. Now we see that our Cronbach's alpha for life satisfaction items is 0.89. It's really high. And when we look at the LifeSat items, reliability if an item is dropped, the only one that really makes a difference is if we did not include LifeSat 5, our Cronbach's alpha would increase from 0.89 to 0.90. But again, all of these are over 0.7. That's our goal, is to know that the items hang well enough for combining to a skill level score. And because this is how the scale was developed, having all 5 items, we're not going to make any changes to how it's combined. So looks okay. Now we're ready to sum the items to a composite skill level score for total life sat. And we do this the same way as we did total optimism. So you can either copy paste or you can just write it out. I want Lab1, new variable T life sat, and I want it assigned by row sums from the Lab1 data set, open bracket, comma C, open parenthesis, and now I want my list of items. Okay, let's check it over, see if it's exactly like this one. Looks like I still need my ignore the missing variables statement. Okay, now we have a new variable there. And again, if we want to check the names of all the variables in the data set, we can do that. And we have our life sat. Where is, I'm not seeing our total optimism in here. So I'm going to go back and make sure that that's run. Oops. Let me try names again. There it is. Maybe I forgot to run it before. So we got our two completed skill scores as well. And you should have all of your coding in here in the lab script. And we want to resave the data frame now that we've done all these changes to it. So I'm going to look for where I did that before, right there. And I'll copy that and bring it down here. And command run. Sweet. So you want to save your R script and make sure you've saved your data frame. And that is our tasks for RStudio. We covered a lot here, right? You navigated a new interface, especially RStudio, ran into some snags here and there, but that's exactly what it's like, that we work our way through it as you see things come up. We imported a CSV file with data, cleaned the data up, and evaluated the internal consistency of some items so that we could create skill level scores. You saved some files, so you're ready to move on to your next lab.